Every business depends on its ability to produce efficiently, reliably, with consistent quality, on cost target, and to deliver products on time to its customers. At the heart of manufacturing lies its production machines. The efficiency and reliability of the machines and the production capacity of these machines directly influence a company's ability to meet demands, remain profitable, and survive the competition. Let's get started. Welcome to Lesson 7. In this lesson, we'll uncover how maintenance protects your present, how expansion shapes your future, and how both decisions come alive in the business simulation game you're going to play. In the business simulation game, you learn to make decisions that will impact your cost structure, that ultimately impact your reliability in producing the volume you plan to produce, and your ability to capture the potential demand generated through marketing and quality improvement efforts. By the end of this lesson, you should be able to understand the impact of maintenance on the efficiency of production machines and the cost make the finished goods. Recognize the importance of capacity expansion as a strategic move for business growth. Master the management process for making sound decisions on maintenance, expense, and equipment investment in the business simulation game. To play the business simulation game well, you need to apply a disciplined analysis round after round using a business intelligence decision matrix. Your choices will determine whether you can maintain competitive costs to produce efficiently and respond to demand to ensure availability of your product to your customers. Let's get started. Neglecting maintenance leads to lower production efficiency reflected in increased scrap and rework, as well as production delays due to breakdowns and higher costs in emergency repairs. Obviously, raw material also goes to waste, brought about by scrap and rework. Neglecting capacity expansion leads to undercapacity reflected in inability to produce the desired quantity to meet rising demand. When potential demand is not met by the volume of production due to a limit in production capacity, the result is lost opportunity for revenue and profit. Obviously, the heavy investment in marketing and R&D to increase demand also goes to waste because demands generated fail to become sales. Maintenance protects what you have, lowering wastage and lowering the cost of producing the finished goods. It determines how well you can do today. Capacity expansion builds tomorrow's growth potential, meeting rising demands and achieving bigger sales and profit. It determines how far you can grow tomorrow. Decisions on the maintenance expense and the equipment investment will shape the competitiveness of the company. Not doing enough or overdoing both comes with risks. Over-maintenance adds no value to higher productivity. It is the effect of diminished return. Overexpansion adds no value to doing more business. Excessive capacity not utilized is sink cost. Both are a waste of precious capital that can be invested elsewhere, more critical to the operations of the company. Now, do you understand why and how both decisions shape the competitiveness of the company? In the business simulation game, the effect of scrap and rework is reflected in a conversion rate or material conversion factor, max equals 1. For example, a conversion rate of 0.7 means 1 unit of raw material only turns out 0.7 unit of finished goods. Effect of breakdown and emergency repairs is reflected in the operating expense. You could choose a strategy of reactive maintenance, which means low to no maintenance expense, and the result is continuous decline in productivity and a high cost in operating expense later. You could also choose a strategy of preventive maintenance, which means consistent maintenance expense, and the result is a stable conversion rate and a stable cost, adding to the operating expense throughout. Managers must decide how much to spend on maintenance, neither over nor under. A consistent level of preventive maintenance now is advisable to avoid costly corrective maintenance later. The rules of thumb that may help you are: most firms invest 3% to 5% of equipment value in maintenance. This is an average practice that applies to most industries. Most firms also aim at keeping the conversion rate between 0.7 to 0.8, which is considered optimal. Capacity expansion is a strategic lever to be used carefully. While production capacity declines naturally due to wear and tear, which needs compensation anyway, the high capital cost of capacity expansion brings financial risks due to uncertainty in the market dynamics. Equipment investment involves heavy capital, and the payback may take a long time. There is always the risk of underutilization if higher market demand does not materialize. The future of the market is so volatile and unpredictable that the equipment investment only pays off if the market environment is favorable and the business strategy works out as planned. Core principle in capacity expansion is that equipment investment should be guided by careful demand forecasting, competitive positioning, and financial feasibility analysis. The rules of thumb that may help you: typically, manufacturers expect between 2% to 10% of capacity decline annually due to wear and tear, depending on the industry. In the simulation game, production capacity is set to decline at 0.5% every business period. And every $20 in equipment investment increases the capacity by 1 unit of finished goods in the next period. Capacity expansion strategy can be categorized into 3 approaches. Incremental expansion, adding small units of capacity over time, minimizing financial risk by making incremental investment in capacity expansion to compensate for capacity decline, as well as to add capacity moderately to be ready for growth. Aggressive expansion, making large-scale expansion to support ambitious growth plan by investing heavily upfront to gain cost advantage and dominate the market. Wait and see expansion. Do nothing until the trend becomes apparent in terms of increased demand. Each strategy has different risks and reward profile. Potential demand could fluctuate widely due to market dynamics. Large-scale expansion is very risky without a well-thought-through growth strategy in place. Holding off expansion for too long until increased demand is certain risks prolonged capacity shortfall. Incremental expansion with moderate capacity increment is the safe bet. The rules of thumb that may help you: most firms consider utilization factor of 70% to 85% as the optimal levels. When production utilizes over 85% of the capacity, that is to say, when utilization factor goes beyond 85%, making equipment investment to add 15% of production capacity at a time is considered optimal to most firms. In the business simulation game, overtime production allows for 50% more production capacity. The cost of production for the additional 50% finished goods is $1.25 per unit more than that produced within the normal production capacity. In each round of the business simulation game, a decision must be made on the amount you want to allocate to maintenance expense to keep efficiency and reliability up in order to save costs, and a decision must also be made on the amount you want to allocate to equipment investment to keep production capacity up in order to meet increased demand. These are the core questions you will ask. How much should we spend on maintenance? How do we know if we are over or under spending on maintenance? How much should we spend on equipment investment? How do we know if we are over or under capacity? You will apply the plan, do, check, adjust cycle to make decisions in the operations of the company over multiple business periods. You will generate a business intelligence decision matrix like this one as a tool to help you make sound and logical decisions. The decision column is maintenance expense. The outcome column is conversion rate attained in the same period. The KPI column is a yes or no, whether the conversion rate in the period is within 0.7 to 0.8 range. During the lessons, you are at the middle of a business simulation game that had gone through 4 rounds, and all the data and information are at your disposal. You just need to find them. You can find the decision on maintenance expense in the Business Decisions Decision History page. You can find the conversion rate in the Performance Financial Statement page. You must fill up all the cells. Start with reviewing your performance in the past 4 rounds. Go over the control steps. The goal is to assess the effectiveness of maintenance decisions. The standard that defines good performance is having the conversion rate kept between 0.7 to 0.8. The performance to review is the movement of the conversion rate in the past rounds. The correction that can be made is to spend more or less on maintenance in the next round. Ask the question and answer it yourself. How did the conversion rate change in response to maintenance expense? What correction should be made to bring performance to meet standard? Having decided on the correction, go over to the plan steps. Some explanation to the rules of the game will help you understand what you are doing. The conversion factor is best kept stable between 0.7 to 0.8. The material conversion factor, or conversion rate max 1, refers to the number of finished goods produced with 1 unit of raw material, and the key factor to influence it is the maintenance expense. The relationship between the level of maintenance expense and an improvement of, say, 0.01 inches material conversion factor in non-linear. It costs less to improve more at the lower end of the conversion rate than at the higher. There is no formula for computation. In playing the business simulation game, we should make small changes in the first few rounds to understand the effect before making any bold move in later rounds. Now go over the planned steps. The goal is to keep the conversion rate at optimum. What is optimum depends on your circumstances. You may be desperate for higher yield, which will lead you to spend more on maintenance in the next round. The strategy is regular upkeep, which is a safe choice. The forecast is what you expect to achieve in the next multiple rounds. The budget is the financial resource needed, and you should make sure it is available. Ask the question and answer it yourself. What do I want to happen in the next rounds? And what should I spend on maintenance for the next round? You will apply the plan, do, check, adjust cycle to make decisions in the operations of the company over multiple business periods. You will generate a business intelligence decision matrix like this one as a tool to help you make sound and logical decisions in capacity management. The decision column is equipment investment. The outcome column is next production capacity for next round reported in this period. The KPI column is the utilization factor of this period. You need to calculate this PKI. The formula is production volume this period. Next production capacity for next round reported in this period. During the lessons, you are at the middle of a business simulation game that had gone through 4 rounds, and all the data and information are at your disposal. You just need to find them. You can find the decision on equipment investment in the Business Decisions Decision History page. You can find the next production capacity for the next round, as well as the production volume in this round in the Analysis Production Logistics page. You must fill up all the cells. Start with reviewing your performance in the past 4 rounds. Go over the control steps. The goal is to assess the effectiveness of equipment investment decisions. The standard that defines good performance is having the utilization factor between 70% to 85%. The performance to review is the movement of the utilization factor. The correction that can be made is to spend less or none on equipment investment in the next round. Ask the question and answer it yourself. How did the utilization factor change in response to equipment investment? What correction on equipment investment would I make and why? Having decided on the correction, go over to the plan steps. Some explanation to the rules of the game will help you understand what you are doing. The rule of the game that may help you. The primary goal of equipment investment is to maintain an optimal utilization of the production capacity. Most firms consider 70% to 85% as optimal. The relationship between equipment investment and an improvement in production capacity is linear. Every $20 investment results in capacity increase of 1 unit of finished goods in the next period. An allocation of equipment investment will also increase the miscellaneous expense for equipment investment, which covers insurance premiums, shipping rate, and relevant expenses amounting to 0.0001x equipment investment. Equipment investment should be no more than half of the equity of each period. This is to avoid depletion of cash that would significantly increase risks in fund shortage for business operations. The key to running the company competitively is to anticipate the production capacity needed for the future and make investment well in advance. In playing the business simulation game, we should make small changes in the first few rounds to understand the effect before making any bold move in later rounds. Now, go over the plan steps. The goal is to keep the utilization factor optimum. What is optimum depends on your circumstances. You may want to have more cash and not invest, risking under capacity. This goal will lead you not spend on equipment investment in the next round. The strategy is to increase capacity moderately by investing over multiple rounds to bring capacity up 15%, then stop. The forecast is the optimum you expect to achieve in the next multiple rounds. The budget is the financial resource needed, and you should make sure it is available. Ask the question and answer it yourself. What do I want to happen in the next rounds, and what should I spend on equipment investment for the next round? After each round, reflect on: did you balance cost and growth potential? How did expansion strategy affect cash flow? What risks did your capacity expansion choices create? Decisions made in maintenance expense and equipment investment balance cost efficiency with reliability and flexibility. In the business simulation game, as well as in the real world, these decisions determine whether your production system runs smoothly and whether your business can compete in dynamic markets.